Good morning, everybody. Thank you for coming by Living in the HOA today. And today we have a special video for you. It's a very important video. It's about a basic process that trees go through, and which it gives us one of the major benefits or products of a tree's growth, and that is air conditioning. Trees, I don't know whether you know it or not, but trees are basically huge air conditioning units or evaporative coolers, and that's what we're going to be talking about today. We're going to be discussing how that is and what trees do in order to provide that service. So here on Living in the HOA, one of the purposes of our channel is to familiarize you with trees and the benefits of trees and what they do in proper management of trees. And something that's fundamental to that is understanding how trees go about providing you these services. And I hope this is interesting for you. It's certainly interesting to me. It turns my crank. You know, it really helps me understand and appreciate trees. And so by doing this and by providing you this information, I hope that it helps you appreciate trees, how trees have become to the way they are, and they are unique. They're not like shrubs. They're not like this bougainvillea. They're not like these orange jubilees and the yellow bells and all of this. They're not like that at all, even though they are similar in some ways in terms of their processes, their biological processes. They're all woody plants, but trees are unique. As you can see in this tree, it's got a trunk, its crown is very high in the air, and we'll talk about that today because that's critical to what they do and how they provide this air conditioning service for your community. And so that's what I want to start off with today. I want to talk about the process that they go through. Of course, in a previous video, we talked about how trees gather water through their root systems, and the root systems are very dispersed. Even though you can't see them, they're underground. The trees' roots are out sometimes twice the diameter of the crown, out in the soil, where their mission is to gather water and to do it every way they can. And so these roots do that. They go down, they start big and they go down to very fine roots and actually root hairs. And even beyond that, they have joint relationships and symbiotic relationships with fungus that have even smaller roots that go out and collect water and oxygen and nutrients and exchange it with the tree's roots, so that the tree will then provide the fungus some of the sugars that they produce in these things, the leaves and up in the crown. So they do that, and it's a symbiotic and very important and critical relationship that they have. And so they send the water up through the root systems all the way up to the trunk here, and in the trunk there's specific kinds of tissues that are connected, going up and down vertically, and they're open on the ends, and each one connects to the other all the way up this the trunk, up to the branches, and then out to the even smaller branches, and then to the leaves. This is called xylem, and xylem is designed to transfer water. It's like tube systems that sends water up the tree, all the way up from the roots, up the trunk, up to the branches, and then out to where the leaves are. And the whole structure of this tree is designed to hold those leaves up in the air and up so they can reach the sunshine and not be having to compete with these smaller plants. And this is a scaffolding is actually what it's called, and they're designed to hold the leaves up in the sunshine so that they can perform the various services that the leaves do, and that is to produce food, to make sugars within the tissues of these leaves, and to take in carbon dioxide, and to receive water that's sent up through that trunk and the branches to these leaves. And they combine that sunshine that they get from the sky with the carbon dioxide that they receive from the atmosphere. That goes into the tissues, and these specific little molecules in tissues, cells called the chloroplasts, and the chloroplasts perform this wonderful activity called photosynthesis, where they receive these materials, the water and the carbon dioxide, and they combine it in specific ways to form sugar molecules, glucose, that is then sent back down through the branches and through the trunk all the way into the roots and out to the root hairs where they exchange it. They also use that material to give the tree energy and give it the ability to grow and make more tissues and all of that. And so that is a sugar, and that's what this organism exists on, and basically every living thing on the earth operates on those sugars that are created by this plant right here in these little leaves. It's a wonderful thing. It's just a miracle that they're able to do this. Scientists still don't know exactly how they do it, how they integrate the sunshine with the water and the carbon dioxide, and to do all this and then create the organic molecules that we know as sugars that we can actually eat and all other animals eat. That's why we have grazers that eat the leaves, and sometimes we eat the leaves of these plants as well, to get the sugars and the energy that comes from that. So, but what I wanted to talk about today is an additional process that's a corollary to that, and it happens during the creation of these sugars and the photosynthesis, and that is the processing of water through these tissues. And that's what makes these organisms here a big air conditioning system. These are actually the biggest air conditioners that you will ever see. And so essentially trees are gigantic air conditioning systems, misting systems that lower temperatures, evaporative coolers, they're all of that balled into one. And it's a wonderful product that they give us to do that, and it's a miracle that they can do it. So what happens is during this photosynthesis process, the trees use the water, take in that water, and they only use a very small amount of it, maybe 10% or less, maybe 6% of it, they use in that biological process to produce the sugars, and the remaining, what's left over of that water, they exude, they send out through little holes in these leaves, the very tiny, tiny holes, you can't even see them, tiny little holes in the bottom of the leaves called stomates or stomata, this plural, and they exude water through that. That's wastewater or leftover water, and they put it out through these little stomates where it evaporates from the surface of that leaf. And so when that water evaporates from the leaf, it needs energy to do that, to change from the liquid form to the vapor form, which will float in the air. And when it does that, they need energy, and they get that energy from the air, and that energy is in the form of heat. And so that water then takes in heat from the atmosphere around these leaves in a very small distance from the leaves, and then farther away as well. They take in that energy, and then that allows them to allows the water to jump from the liquid phase over to the vapor phase and then float away and evaporate and just go away. And so when they do that, that energy that they take in cools the air. And that's how an evaporator cooler works, the same way. But they are mechanical systems and they have spongy material where water is put on there. And when that water evaporates, it changes from the liquid phase to the vapor phase on those pads that they have in there. Then it cools the air around them, and the fans drag that air into the pipe system in the house and distributes it to the house as cooler air. But here on these systems out here in the open, it cools the air around these leaves. So scientists have looked at this before and have seen that air can be reduced in temperature, sometimes between 3 degrees and 12 degrees lower in temperature. And so it actually cools the air around these leaves, and when the wind blows across it and takes that cooler air, it cools everything around. Everything. Thank God for the jets that are flying around today as well. But the atmosphere is actually cooled because the leaves are pulling, and by evaporating the water, they're pulling energy out of the atmosphere, which cools it. And so they are acting like large air conditioners or evaporative coolers. And even as misting systems. These are tiny, tiny, tiny little misting systems, but the volume of them all together is huge. This tree has thousands or maybe tens or hundreds of thousands of leaves on it, and as the tree grows, it gets more and more leaves. So that process of evaporating the water from the surface of these leaves cools the atmosphere and allows us to have the benefit of cooler airs. Now, many people think that the way trees give us a cooler environment is just through shade. Shade is only part of it. Shade is actually only a smaller part of it. The major part of it is the air conditioning that we get, the evaporative cooler systems that are operating up through the tree from the roots through to these leaves, where the water evaporates and cools down the air, actually cools the air around these branches, and it takes it on. The wind will come by and take that cooler air out. And so when you have many trees, for instance, when you have a forest, we know that when you walk through a forest, it automatically feels cooler. And that's not just because of the shade. Shade is one part of it. But the major part of that cooling is the lower temperatures in the air that is created by the evaporation of water. This is called transpiration, because it transfers the water up from the ground to the leaves in the trees, and there is where it performs the magic of photosynthesis, and the leftover water, the major part of the water, is evaporated off, and that is called transpiration. Not just evaporation, it's transpiration. Evaporation can occur mechanically without leaves. For instance, when you've got water on the sidewalk or on the pavers at your house, the water, just because of the physical processes of evaporation, will take that water just as a physical process and evaporate it away, and it will, the cooling that it does will be on those surfaces. But here on the biological process of transpiration happens in these leaves and on the surface of these leaves and in the air surrounding the leaves. So there was a study that was done that was published in 2024, and it was actually a multi-year study that was funded by the U.S. Geological Survey, and they looked at this process of evaporative cooling that trees do in cities all across the western part of the United States. Phoenix was included in that study, as well as Las Vegas, Los Angeles, Denver, and other cities around. And what they found was that this process of cooling, the process of evaporative cooling, is exacerbated. In other words, it's amplified the drier the air is. And of course, we live here in a very dry place. Today, the humidity level is 19%. I checked it before we started this video. And I've seen it go down to 8%. And so that makes the evaporation happen even faster and takes more heat out of the atmosphere. So when this evaporation process is sped up, it speeds up during the hottest times and the driest times in these arid environments, in these neighborhoods. Actually, the evaporation process, the evaporative cooling that trees do, becomes more effective and even larger in effect, and helps cool down the neighborhoods. So what I wanted to get across to you today is the marvel of this process of evaporator cooling, how it happens, how it benefits us. It actually lowers the temperature of the environment around us. That's what trees do. It's not just that they give oxygen as a byproduct of the photosynthesis process, which they do, but they also lower the temperature around them, and it's cumulative. The more trees you have, the more cooling there is. So when we have trees that are in the backyards and the front yards of these homes, as well as in the common areas of the HOA, then that evaporator cooling, the evaporative cooling, is greatly multiplied. And so that is how the trees benefit us, by lowering the temperatures of the environment. And that's very important because, for instance, today, here where I live in Phoenix, Arizona, the temperature is going to be about 113 degrees. It was 112 yesterday. Last week it was 116. So these reductions in temperature that occur because of these trees are very important. They're extremely important. It's a health issue for people that live in this area. So we need to encourage our HOAs and anybody else that is responsible for managing the trees to manage them well and to keep them healthy, because unhealthy trees can't do that process. They wilt and they drop their leaves, but a healthy tree will maintain its leaves like this and can do the photosynthesis and the evaporation, the transpiration from these leaves, and help lower the temperatures in the environment. So I just wanted to mention that to you. The study that was done proved this. The drier it is, the more effective this process of transpiration, of evaporation becomes, and it helps us more. Many times the temperature is so high it doesn't feel like it, and you're not out where you notice these things. We're inside our houses and enjoying the mechanical air conditioning. But when we come out, these are the organic air conditioners. These are the ones that actually cumulatively cool the atmosphere, give us the benefits of the trees, and plus the shade. So when you combine this evaporative cooling and the lowering of the temperatures plus the shade, you combine that with the shade, you can see that is shadier here. It prevents the sun from coming down and heating the granite, the decomposed granite that is on the ground, the patio areas, the pavers, and in many instances even the pavement of the streets and sidewalks. So we get the combined benefits of the shade and the evaporative cooling that the trees provide, and those two things together are just tremendous in what they do for our neighborhoods. So I'm telling you that because I want you to appreciate trees and to be able to understand how important trees are. But the trees are extremely important. I'm such an advocate of trees. I'm an advocate of HOAs because they are the administrative organization that helps maintain all these trees in healthy condition so that they can perform these processes and give us the benefits of them. So I just wanted to talk with you about that today, and I'm going to, as we go through this video, I'm going to be showing you other trees that we have in the neighborhood that are been planted around and contribute to what's called the urban forest. This is a part of the urban forest here in our neighborhood. This is one little piece of it that I'm responsible for, that I manage, and I have to keep healthy. And this tree, this is a healthy live oak tree. And so it's my responsibility as the land manager of my little piece, my one lot of that overall urban forest. I'm proud of it. I like doing it. I understand the value of it. So I'm going to be continuing to do that. And this is what I want to get across to you as well, so that you will build an appreciation and then value these things, these trees, because of what they do, the miracles that they perform in helping our environment that then helps us, and that you will continue to watch as we post videos about how to properly manage these trees to keep them healthy, and the processes that they go through. I'll be talking about all these biological processes of trees as well, the hydrological processes of the water, about the irrigation systems that are required here where we live in Arizona. We'll even be talking about the recharge of the water. In other words, the water goes back down into the ground in our common areas and our retention basins. And so we'll be talking about all that as well. So thanks for stopping by. I appreciate you paying attention. If you have any questions or you get any comments, please put them down below, and subscribe to the channel so we can continue to grow the channel and have outreach to other people in the neighborhoods, in HOAs. Hopefully board members will be watching this as well, community managers as well as members of the community, to learn how to better take care of the trees. Okay, thank you so much for coming by, and we'll see you in the next video. Bye-bye. Here I wanted to show you another tree. This is an Arizona ash tree, and it looks very different. It has different kinds of leaves on it, but it's still like other trees. It has a trunk, and it has the branches, and it has the leaves, and its roots are all underground right here. So it's still a tree, but it's a different species of tree. But it performs exactly the same role that the other tree does. The leaves are a little different. They're broader leaves, as you can see here. And so they have more of the material that performs photosynthesis, and they have more stomates or stomata underneath this leaf, on the bottom of the leaf, but they perform exactly the same functions that the other tree did that I showed you, the live oak tree. But this is an Arizona ash tree. Across in the neighborhood, as you can see over there, there's more live oak trees, and there are a tree called a sisu tree over there. You can see them over here as well. And there's quite a few trees in this neighborhood, and you can see them all down through the neighborhood here. And these are critical organisms. These are critical for the survival of this area, to keep it at least reasonably cool, and they all perform the same functions. Okay, everybody, I wanted to take you to another part of the community. This is a retention basin in the community. I don't know if you can see it or not here. The retention basin is quite large. Many people call it a park, and recreation and use as a park is only a secondary service that this area provides. But mainly this is a retention basin, and what it does is here you can see where the water runs off from the street down through this sort of a sluice runoff area here, and the water goes down into the retention basin, where it is retained and until it can go back into the soil and down into the groundwater. And you'll also see around here there are some areas that have manhole covers or drain grates, and we'll be talking about those in a future video about what they are and why they're there. But I wanted you to see around this retention basin, you see all the trees around the retention basin, it is surrounded by trees, and those trees perform exactly the same functions as we were talking about with the tree in my backyard and in my front yard and the trees up and down the street. So I wanted you to see that these trees, this is part of the urban forest that is under the management of the HOA of this community. They are responsible for managing it. We give them dues every month to provide them the financial resources to hire the maintenance people and to do the work that's necessary for these areas, to maintain the trees, to maintain the grass, to maintain the shrubs around the edges of it. You can see the shrubs around the edges there as well. That is the responsibility of the HOA. The trees that surround this area, all around here, there's also on this side, you can see the trees there. They perform exactly the same function as the other trees. They do evaporative cooling. They process water up from the roots to the leaves where it evaporates and cools the air. So all of these trees together, all of them are cumulative in terms of the services that they provide and the benefits that we get from them. So I wanted you Okay, this is a community. This is a road actually that runs along the east side of our community. You can hear the cars going by. And what I want to show you is I want to show you how the city is working with the various HOAs to put trees in this community. And you can see here down the road this way, all down through there in the median. These are called pistache trees, Chinese pistache trees, and they're all in that median, all the way down along that area there in the community. And those complement the various kinds of trees that the community puts in as well. And you can see the community trees down this way as well. And on the west side where our community is, you can see the community trees there as well in that landscaping. And over there we have mesquite trees. There are a few sisu trees, which are otherwise known as Indian. There's an Indian species of tree. Indian rosewood is what it's called. And so that's over there. We also have some Palo Verde trees over there, and up and down, all up and down that area as well. And so all these trees perform exactly the same function as what I told you about the tree in my backyard. Okay, this area is along the north boundary of our community, and with a public road here. You can see the public road goes that way, east and west. And here in this area, the design of the community is such that there are many trees that are put down in this area here. On the side that is nearest this drainage area, this is a drainage area down here, there are sisu trees, which are the Indian rosewood trees. And those were installed because they are, they grow fast, they provide a lot of green foliage, and the designers of these communities like that. But the problem is the roots are very invasive, and they go a long ways, and they come under the sidewalks. You can see the roots of this tree right here. The roots are very invasive down here, and they're running laterally across the surface of the soil. So this is one of the disadvantages of the Indian rosewood or the sisu tree that the designers perhaps didn't understand when they put them in. And along the road, along this way, the trees that you have along the road are live oak trees. And the live oak trees are like the ones I showed you before in my backyard. These trees, the live oak trees, have smaller leaves, much smaller leaves. These have been in place for 13 years, 14 years. So they are a little older than the trees in my backyard, but mine are much larger than these trees because they've been watered more. These trees are stressed and they are stunted because of receiving less water than the trees in my yard. So trees will get stunted like that if they're not getting enough water, and so they stay small that way.